Text mining, also referred to as text data mining, roughly equivalent to text analytics, is the process of deriving high-quality information from text. High-quality information is typically derived through the devising of patterns and trends through means such as statistical pattern learning. Text mining usually involves the process of structuring the input text, usually parsing, along with the addition of some derived linguistic features and the removal of others, and subsequent insertion into a database, deriving patterns within the structured data, and finally evaluation and interpretation of the output. High quality in text mining usually refers to some combination of relevance, novelty, and interestingness. Typical text mining tasks include text categorization, text clustering, concept/entity extraction, production of granular taxonomies, sentiment analysis, document summarization, and entity relation modeling, i.e., learning relations between named entities. Text analysis involves information retrieval, lexical analysis to study word frequency distributions, pattern recognition, tagging/annotation, information extraction, data mining techniques including link and association analysis, visualization, and predictive analytics. The overarching goal is, essentially, to turn text into data for analysis, via application of natural language processing, NLP, and analytical methods. A typical application is to scan a set of documents written in a natural language and either model the document set for predictive classification purposes or populate a database or search index with the information extracted. Text analytics. The term text analytics describes a set of linguistic, statistical, and machine learning techniques that model and structure the information content of textual sources for business intelligence, exploratory data analysis, research, or investigation. The term is roughly synonymous with text mining. Indeed, Ronan Feldman modified a 2000 description of text mining in 2004 to describe text analytics. The latter term is now used more frequently in business settings while text mining is used in some of the earliest application areas, dating to the 1980s. Notably life sciences research and government intelligence. The term text analytics also describes that application of text analytics to respond to business problems, whether independently or in conjunction with query and analysis of fielded, numerical data. It is a truism that 80% of business-relevant information originates in unstructured form, primarily text. These techniques and processes discover and present knowledge facts, business rules, and relationships that is otherwise locked in textual form, impenetrable to automated processing. Future. Increasing interest is being paid to multilingual data mining, the ability to gain information across languages and cluster similar items from different linguistic sources according to their meaning. The challenge of exploiting the large proportion of enterprise information that originates in unstructured form has been recognized for decades. It is recognized in the earliest definition of business intelligence, in an October 1958 IBM Journal article by H. P. Lunn, a business intelligence system, which describes a system that will utilize data processing machines for auto-abstracting and auto-encoding of documents and for creating interest profiles for each of the action points in an organization. Both incoming and internally generated documents are automatically abstracted, characterized by a word pattern, and sent automatically to appropriate action points. Yet as management information systems developed starting in the 1960s, and as BI emerged in the 80s and 90s as a software category and field of practice, the emphasis was on numerical data stored in relational databases. This is not surprising. Text in unstructured documents is hard to process. The emergence of text analytics in its current form stems from a refocusing of research in the late 1990s from algorithm development to application, as described by Professor Marty A. Hurst in the paper Untangling Text Data Mining. For almost a decade, the computational linguistics community has viewed large text collections as a resource to be tapped in order to produce better text analysis algorithms. In this paper, I have attempted to suggest a new emphasis: the use of large online text collections to discover new facts and trends about the world itself. I suggest that to make progress we do not need fully artificial intelligent text analysis. Rather, a mixture of computationally driven and user-guided analysis may open the door to exciting new results. Hurst's 1999 Statement of Need fairly well describes the state of text analytics technology and practice a decade later. Text analysis processes. Subtasks. Components of a larger text analytics effort typically include: information retrieval or identification of a corpus is a preparatory step, collecting or identifying a set of textual materials, on the web or held in a file system, database, or content corpus manager, for analysis. Although some text analytics systems apply exclusively advanced statistical methods, many others apply more extensive natural language processing, such as part of speech tagging, syntactic parsing, and other types of linguistic analysis. Named entity recognition is the use of gazetteers or statistical techniques to identify named text features, people, organizations, place names, stock ticker symbols, certain abbreviations, and so on. Disambiguation. The use of contextual clues may be required to decide where, for instance, Ford can refer to a former U.S. president, a vehicle manufacturer, a movie star, a river crossing, or some other entity. Recognition of pattern-identified entities, features such as telephone numbers, email addresses, quantities, with units, can be discerned via regular expression or other pattern matches. Coreference, identification of noun phrases and other terms that refer to the same object. Relationship, fact, and event extraction, identification of associations among entities and other information in text. Sentiment analysis involves discerning subjective, as opposed to factual, material and extracting various forms of attitudinal information, sentiment, opinion, mood, and emotion. Text analytics techniques are helpful in analyzing sentiment at the entity, concept, or topic level and in distinguishing opinion holder and opinion object. Quantitative text analysis is a set of techniques stemming from the social sciences where either a human judge or a computer extracts semantic or grammatical relationships between words in order to find out the meaning or stylistic patterns of, usually, a casual personal text for the purpose of psychological profiling, etc. Applications. The technology is now broadly applied for a wide variety of government, research, and business needs. Applications can be sorted into a number of categories by analysis type or by business function. Using this approach to classifying solutions, application categories include: enterprise business intelligence/data mining, competitive intelligence, e-discovery, records management, national security/intelligence, scientific discovery, especially life sciences, sentiment analysis tools, listening platforms, natural language/semantic toolkit or service, publishing, automated ad placement, search/information access, social media monitoring, security applications. Many text mining software packages are marketed for security applications, especially monitoring and analysis of online plain text sources such as internet news, blogs, etc. for national security purposes. It is also involved in the study of text encryption/decryption. Biomedical applications. A range of text mining applications in the biomedical literature has been described. One online text mining application in the biomedical literature is PubGene that combines biomedical text mining with network visualization as an internet service. GoPubMed is a knowledge-based search engine for biomedical texts. Software applications. Text mining methods and software is also being researched and developed by major firms, including IBM and Microsoft, to further automate the mining and analysis processes, and by different firms working in the area of search and indexing in general as a way to improve their results. Within public sector, much effort has been concentrated on creating software for tracking and monitoring terrorist activities. Online media applications. Text mining is being used by large media companies, such as the Tribune Company, to clarify information and to provide readers with greater search experiences, which in turn increases site stickiness and revenue. Additionally, on the back end, editors are benefiting by being able to share, associate and package news across properties, significantly increasing opportunities to monetize content. Business and marketing applications. Text mining is starting to be used in marketing as well, more specifically in analytical customer relationship management. Kusment and Van den Poel, 2008, apply it to improve predictive analytics models for customer churn, customer attrition. Text mining is also being applied in stock returns prediction. Sentiment analysis. Sentiment analysis may involve analysis of movie reviews for estimating how favorable a review is for a movie. Such an analysis may need a labeled data set or labeling of the effectivity of words. Resources for effectivity of words and concepts have been made for WordNet and ConceptNet, respectively. Text has been used to detect emotions in the related area of effective computing. Text-based approaches to effective computing have been used on multiple corpora such as students' evaluations, children's stories, and news stories. Academic applications. The issue of text mining is of importance to publishers who hold large databases of information needing indexing for retrieval. This is especially true in scientific disciplines, in which highly specific information is often contained within written text. Therefore, initiatives have been taken such as Nature's proposal for an open text mining interface, OTMI, and the National Institutes of Health's Common Journal Publishing Document Type Definition, DTD, that would provide semantic cues to machines to answer specific queries contained within text without removing publisher barriers to public access. Academic institutions have also become involved in the text mining initiative. The National Center for Text Mining, NACTEM, is the first publicly funded text mining center in the world. NACTEM is operated by the University of Manchester in close collaboration with the Tsuji Lab, University of Tokyo. NACTEM provides customized tools, research facilities, and offers advice to the academic community. They are funded by the Joint Information Systems Committee, JISC, and two of the UK research councils, EPSRC and BBSRC. With an initial focus on text mining in the biological and biomedical sciences, research has since expanded into the areas of social sciences. In the United States, the School of Information at University of California, Berkeley is developing a program called BioText to assist biology researchers in text mining and analysis. The Text Analysis Portal for Research, TAPR, currently housed at the University of Alberta, is a scholarly project to catalog text analysis applications and create a gateway for researchers new to the practice. Digital Humanities and Computational Sociology. The automatic analysis of vast textual corpora has created the possibility for scholars to analyze millions of documents in multiple languages with very limited manual intervention. Key enabling technologies have been parsing, machine translation, topic categorization, and machine learning. The automatic parsing of textual corpora has enabled the extraction of actors and their relational networks on a vast scale, turning textual data into network data. The resulting networks, which can contain thousands of nodes, are then analyzed by using tools from network theory to identify the key actors, the key communities or parties, and general properties such as robustness or structural stability of the overall network, or centrality of certain nodes. This automates the approach introduced by quantitative narrative analysis, whereby subject-verb-object triplets are identified with pairs of actors linked by an action, or pairs formed by actor-object. Content analysis has been a traditional part of social sciences and media studies for a long time. The automation of content analysis has allowed a big data revolution to take place in that field, with studies in social media and newspaper content that include millions of news items. Gender bias, readability, content similarity, reader preferences, and even mood have been analyzed based on text mining methods over millions of documents. The analysis of readability, gender bias, and topic bias was demonstrated in FLANAS et al. Showing how different topics have different gender biases and levels of readability. The possibility to detect mood shifts in a vast population by analyzing Twitter content was demonstrated as well. Software. Text mining computer programs are available from many commercial and open source companies and sources. See list of text mining software. Intellectual property law. Situation in Europe. Because of a lack of flexibilities in European copyright and database law, the mining of in-copyright works, such as web mining, without the permission of the copyright owner is illegal. In the UK in 2014, on the recommendation of the Hargreaves Review, the government amended copyright law to allow text mining as a limitation and exception. It was only the second country in the world to do so, following Japan, which introduced a mining-specific exception in 2009. However, owing to the restriction of the Copyright Directive, the UK exception only allows content mining for non-commercial purposes. UK copyright law does not allow this provision to be overridden by contractual terms and conditions. The European Commission facilitated stakeholder discussion on text and data mining in 2013, under the title of Licenses for Europe. The fact that the focus on the solution to this legal issue was licenses, and not limitations and exceptions to copyright law, led representatives of universities, researchers, libraries, civil society groups and open access publishers to leave the stakeholder dialogue in May 2013. Situation in the United States. By contrast to Europe, the flexible nature of U.S. copyright law, and in particular fair use, means that text mining in America, as well as other fair use countries such as Israel, Taiwan, and South Korea, is viewed as being legal. As text mining is transformative, meaning that it does not supplant the original work, it is viewed as being lawful under fair use. For example, as part of the Google book settlement, the presiding judge on the case ruled that Google's digitization project of in-copyright books was lawful, in part because of the transformative uses that the digitization project displayed, one such use being text and data mining. Implications. Until recently, websites most often used text-based searches, which only found documents containing specific user-defined words or phrases. Now, through use of a semantic web, text mining can find content based on meaning and context, rather than just by a specific word. Additionally, text mining software can be used to build large dossiers of information about specific people and events. For example, large datasets based on data extracted from news reports can be built to facilitate social networks analysis or counterintelligence. In effect, the text mining software may act in a capacity similar to an intelligence analyst or research librarian, albeit with a more limited scope of analysis. Text mining is also used in some email spam filters as a way of determining the characteristics of messages that are likely to be advertisements or other unwanted material. Text mining plays an important role in determining financial market sentiment.
Please subscribe and thanks for watching.